So, hi everyone, and in this talk I want to talk about how the Rust project handles vulnerabilities in Rust itself. I'm Pietro, I lead the Rust infrastructure team, and I'm also a member of the Rust release team and the security response working group. So I'm kind of in that area of the Rust project, making sure Rust gets delivered to you. And also, as my day job, I work on the Ferrous infrastructure and build system at Ferrous Systems. Ferrous is a qualified toolchain of the Rust project for safety critical uses. So, what is the Rust security response working group? The group is a part of the Rust governance, and it handles all the security vulnerabilities that are present in the Rust project. So ideally, when someone finds a security concern in Rust, they will come to us, and we'll make sure the vulnerability is fixed and disclosed properly. Our job is twofold. We first need to route the vulnerability details to the domain expert, and then we handle all the bureaucracy of disclosing security issues. And crucially, fixing the vulnerability is not in this slide and is not something we do. Because the Rust project by now is really large. We are around 300 people in the project with multiple different sub-projects, and it's impossible for people in the group to have knowledge of how to fix most vulnerabilities. So we prefer to take a step back and instead make sure the domain experts that are the most knowledgeable person of that area of the project are in the know and that will help us fix things. There are currently 2 members of the team, myself and Josh Stone. And it's fine. Rust doesn't receive that many vulnerabilities, so it's a workload we can support. And unfortunately, the work we do is inherently private because we handle vulnerabilities under embargo. So that means vulnerabilities that are not yet disclosed publicly, and we have to keep them private. Otherwise, the details of the vulnerability will be in the public without a fix being available. And so for the security of the ecosystem, it's imperative that we keep everything private. But unfortunately, that means people don't know what we do. And so in this talk, I want to shed a bit of light on how our processes work, how vulnerabilities are handled, and what takeaways you can take for your own projects. This is the list of all the security vulnerabilities that were reported to us and handled in the Rust project since the 1.0 release. And they vary a lot in severity, from just low severity vulnerabilities in cargo we disclosed last month to this really nice buffer overflow in the standard library, because standard library uses unsafe Rust and in some parts, and so vulnerabilities happen there as well, even though it's Rust. And for this talk, I want to pick a specific one, the race condition in remove the role, which was a vulnerability that we disclosed earlier this year. And I want to use it as an example for how we handle vulnerabilities to have an hands-on approach. So first off, what was that vulnerability? I want to give a bit more context so that what we do makes sense. The remove the role function in the standard library is meant to remove a directory and all its child content. And crucially, it does not follow symlinks. So if inside the directory you have a symlink to a different directory, the function will remove the symlink itself, not the contents of the directory the symlink points to. And that's a really important guarantee because it prevents a lot of security vulnerabilities that plague symlinks. And unfortunately, that wasn't properly implemented. And it was possible with a race condition to trick the function into removing an arbitrary directory on the system that was not the one that was passed to the program. And even though it was a race condition, in the proof of concepts we had, we were able to reliably do that within a second. So it was actually pretty serious. And this is not something that concerns most programs, because most programs are executed with the same privileges as the user running the program. And so the user could just delete the directory themselves. The problem appears if you if you can trick a privileged program into removing a directory you control. So like a system daemon or a setUID program like sudo, in those cases, you will be able to do a lot of damage to the system from an unprivileged user, and that's where the vulnerability lies. So of course, the first phase is us knowing that we had this vulnerability and receiving a report. This vulnerability was reported to us by Hans Kratz, and how did he report it? Well, it's explained in our security policy. The security policy for us is a document that explains where to report vulnerabilities, how we will handle them, what's the user response time, and how things will work once you report things to us. And having such a document is really important because every project naturally treats vulnerabilities differently and has different processes. So it's really important for security researchers to know exactly what to report. And in general, security policies should include where and how to report vulnerabilities, maybe via email, via HackerOne, or other things, what the expectation of the response time is, and also if the project has a bug bounty, it's really important to include the scope and possible rewards of the bounty. Bug bounties are a way for companies to reward security researchers once they disclose vulnerabilities, to encourage them to disclose them. And also, those policies should be really easy to find because links to it should be all over the place so that security researchers don't miss them and don't accidentally report vulnerabilities in the open. And for example, for the Rust project, every time you open an issue on GitHub, there is a link to the security policy. And that's something you can configure with issue templates. And once you receive the report, it's crucial to acknowledge quickly. And acknowledgement for us simply means, okay, we received the report, we will look at it soon and let you know once we find more results. And that's because, that's for two reasons. One, it sets expectations on when the reporter can receive a response. Because like, for us, that varies a lot. If we receive a critical security vulnerability, we'll drop everything we do and focus on it. If it's a low security, a low impact thing, we'll do it the next day. But also, it signals to the reporter that they actually emailed their correct place, because maybe the mail got through the spam filter, maybe that mailbox is not monitored anymore, so it's important for them to know that they reached the correct place and don't need to look for other places to report things. And the second step is just reproducing the issue, because some reports are really well written like this one, but some others are less, and in general you need to see if it's actually a vulnerability and if instead you have problems reproducing it or it doesn't work. And that's usually the reporter writes the step they did to get to the security issue, and they're like, just test them. The only suggestion is make sure to use a sandbox or a virtual machine, because like most reporters are in good faith, but it's the internet. People can easily send you a virus through the security email, and that's not a pleasant thing to happen. And for us, like this is one of our practices, is that we immediately then involve the relevant domain experts, which in this case was the lead of the library team, Marabos. And we create a chat room in the Rust Tulip, so we have a place to coordinate, and we bring them up to speed with what the vulnerability is and what we think about it. Because the next step is one of the hardest ones, and is assessing what the impact of the vulnerability is, how severe it is, and what could be the consequences of a program being affected by this vulnerability. This is hard, because especially for libraries, assessing the impact means assessing how users can use that library and where it could go wrong. And occasionally, we miss things. Like, really early in our assessment, we discovered that this vulnerability was also publicly reported on the Rust issue tracker. And after digging a bit, it was reported in the issue tracker because it was sent, I think, in 2018 to the security contact, but then there was made an incorrect assessment, and it was not treated as a security vulnerability, and the reporter was told to open an issue in the public. And this person was Florian Wimmer, and that's unfortunate, but unfortunately it happens. We are all humans, and think this is hard. And it was like, usually when we see a report for a vulnerability that's already public, for us, that's likely an incentive not to treat it as a security vulnerability that we handle. Because if it's already public, there is not really a point in keeping the discussion private and keeping the resolution private because it's already public. And that, of course, depends, because this issue was opened in 2018 and basically received no activity after. And so even though it was technically public, it wasn't something that everyone was aware in that moment. If instead this was a vulnerability that appeared on Reddit, that was discussed for a whole day on Reddit the day before, then we probably wouldn't treat it as something we, the security response working group, handles. So this is not a hard rule that if it's public, we won't handle it, but it depends, as everything. But also, it was trivial to find vulnerable code for this. Like that was actually a really good coincidence. I got access to the GitHub code search private beta the day before. And by the way, it's great. I request access for it, it's so useful. And so I said, like, I didn't have a chance to try it. Let's try searching for remove the role and set UID. And literally the first result was Meta's rewrite of Mercurial in Rust. And that rewrite included a set UID binary that called remove the role on a user control path. So like literally in 5 minutes, I was able to find vulnerable code. And this is not to say the code was bad. The code made assumptions that the standard library had here to its contract, but it wasn't. And this really prompted us to say, okay, let's treat this as a high impact vulnerability, not because it was Meta's code. We don't really do that sort of assessment, but more that it was so easy to find vulnerable code that for sure there are heaps more vulnerable code around. This time we were lucky, other times it takes more time to do this assessment, but yeah, we found a vulnerable project in 5 minutes. And our guiding principle here is minimizing the harm on the Rust ecosystem, which in some cases is just to do things in the public for low priority things, because doing things in the private has a cost, and it basically prevents other feedback and other input from the community and sidestep the whole RFC process. But for severe vulnerability, that causes more harm than good, and so for those, we try to keep everything in private. And the decision for this vulnerability was to treat it, as I said, as high severity, so requesting a CVE ID, treating the vulnerability under embargo, so private up until disclosure, and prepare a point release so that users, once the vulnerability was disclosed, could have a toolchain they could upgrade to and fix things. The next step, of course, was writing and reviewing the fix. We do code reviews for all the fixes. They don't happen in public pull requests, but they are still reviewed. And this problem was actually surprisingly hard to fix, because we didn't have to write a fix. We had to write 3 of them, because the standard library uses a lot of low-level operating systems API, and the implementation for Unix like Windows and WASI, the WASM interface, were all completely different because they use different APIs under the hood. And so we involved the domain experts for Windows and WASI, and also the reporter, Hans Kratz, also helped with the Unix fix. And then they were reviewed by a member of the library team and other people. So for this, we use GitHub security advisories. which is a feature available to all GitHub repositories in the security tab. And if you look at them the first time, you would think they're just a way to signal to your users you had a security vulnerability. But there is this extremely useful feature to start a temporary private fork. With security advisories, you can create a private fork of your repository inside the same organization when you can collaborate on the fixes in a private repository. And that's really convenient. And also, it has a feature to request CVE IDs, even though I'll talk about that later. So we use this feature to collaborate on the fix and get it to a state where it's ready. The next thing was drafting a security advisory. And this is also, like, while writing the fix and reviewing the fix was something that the domain experts did, from now on, all this work is done by members of the security response working group. And drafting the security advisory is surprisingly hard because you need to strike a really good balance between providing all the technical information that a technical person can use to fix the problem on their project, but it also needs to be concise so that a person reviewing multiple advisories a day don't waste all day on your 10-page report. And also it needs to be understandable by people that are less technical and just need to see if their product might be affected. And I'm not a native English speaker, so at least for me it takes a bit of time to strike that balance. But yeah, so those are in a security advisory, you need to make sure to have a really brief overview and what the severity and the possible impact of the vulnerability is. Have mitigations, so how users can solve the vulnerability on their own. And also, it's really important to acknowledge who worked on that advisory, because that builds trust in your security project, in your security program, and allows you to have more reporters responsibly disclosing things to you instead of just posting it on Twitter and surprising everyone. And also in this step, we need to do the final evaluation of the severity, which especially for libraries is surprisingly hard to do. Because the severity we ended up for that vulnerability was high if you use the function in privileged contexts where you had the user control paths, and basically low to none otherwise. And that's something you can write in prose in the advisory, but that's something you really cannot encode in the standard scoring systems of vulnerabilities like CVSS. And because those ones only provide a score like 7.5 or 9.8, and you cannot explain that difference between how the library is used. And so there, the consensus in the security community is to treat this as a worst-case scenario, which in this case resulted in a high score, even though for most users it's not really a high score. And but that's the tools standard in the security industry, so you have to do it. And the next step was actually requesting a CVE ID. You probably saw them all over the news whenever there's a big vulnerability. They're like CVE 2022 and then an incremental number. And CVEs are unique IDs for vulnerabilities that anyone can get. Literally everyone. We have some CVE IDs attached to the Rust project that the Rust project did not ask for. A security research applied for them and they got it. So those IDs are crucial to talk about vulnerabilities with each other because they provide a unique ID you can search for and see all the relevant information. But also, like, often they're not requested by the project, and the project doesn't even know about them. And that can create some confusion. But also, you don't need to be afraid to request a CVE for your small project and your small library. CVEs are free, And especially with GitHub, it's just a click of a button to request them. On the GitHub security advisories, once you fill the advisory, you click the report button, GitHub looks at it before it's public, and if it's actually a vulnerability and you are not just brought random stuff, they'll assign you a CVE ID within a day. And even if you don't use GitHub, other projects can assign CVE numbers, and worst case, you can go to MITRE, the US agency handling CVEs to request one directly from them. And they're not staying in your project. It's not like a project is worse if it has CVE IDs. Actually, in my opinion, it's better because it signals that they have a good security practice. So even if you have a small crate and you find security vulnerability, please request CVE IDs. It's easy and it's free. And finally, there was the big step of disclosing things to the public, which is kind of involved. We have now pretty well oiled the process, but there are still a lot of steps because first off, we need to prepare the actual patch files that will be applied to all different channels. Rust only supports nightly, beta, and the latest stable. We do not support any previous stable. And so at least we need to provide patches for those three. Occasionally, we also provide patches for older versions, depending on the vulnerability. But preparing patches files can be trivial or extremely complex, depending on what the vulnerability is, because we do a lot of refactorings inside the Rust compiler. And so the code might be completely different in 6 weeks, and so you need to write the patch 2 times. And then we disclose vulnerabilities in advance to a limited set of people. And currently that set of people is some Linux and BSD distributions. And we do that to ensure that users have a tool chain they can upgrade to. So that once the vulnerability is released, even if you're using Rust from RustApp as provided by the project or using the Debian package, you can have a fixed tool chain. And I opened earlier this year RFC 3259, which is still open and still up to discussion on extending this approach, not just to those distributions, but having a more general process where interested companies that have a reason to receive vulnerabilities in advance can apply. And finally, we just published the advisory. And so we have multiple places where we do that. We have the official security mailing list, the Rust blog, the GitHub security advisories you saw earlier, and Twitter. And after that, we need to prepare the actual point release. And that's currently the bad thing about our security process, because the Rust release infrastructure can only release when the source code is public. We do not have the ability to pre-build binaries before making the code available, and that means we need to start the release process once the disclosure happens. And if everything goes well, which it doesn't because it's CI, and so spurious failures happen, once we publish the code, we can get our release out in 4 hours. Most of the times it's 8 or 9 because CI fails midway. And that's something we're slowly working to improve, but that's going to take time because it will require a big redesign of how Rust is released. So what was the aftermath of this vulnerability? The first one is not happy. We basically accidentally zero-dayed the C++ ecosystem. And for those who don't know, zero-daying is when you publish the details of a vulnerability without letting the vendor know. And in this case, we didn't let the C++ ecosystem know. And honestly, because we didn't think of it at the time. And turns out both the 2 major implementations of the C++ standard template library and also the Boost library were also affected by this fix. And that's not ideal, and that's something we are going to now be more careful of. And when vulnerabilities will happen, we'll recommend to the reporter to also check other ecosystems and see if they're affected. We will not do it directly for a lot of reasons, both because we don't have that much time, but also because that way the reporter gets the credit even in other ecosystems. But we'll try to make sure it doesn't happen again. And also, we awarded the reporters bug bounty. Rust currently can award bug bounties through the Internet Bug Bounty Program, which handles bounties for a lot of open source projects, including curl. And it's something we signed up earlier this year, and it's something we don't really publicize yet because we do not have had the time to think about a scope and a policy on what deserves a bounty and what doesn't deserve it. So right now is after vulnerability, if we think it's worth a bounty, we email them to contact TBB and get the money. And we are planning to work on a more defined policy that we can actually publish. And once that will be done, it will be more transparent. Right now, we have a lot of stuff to do. This is just the less effort way until we can get to a point to our policy. And also, this might be a bit controversial, but we recommended to the reporter to notify Meta about this vulnerability before the embargo was lifted. And the Rust project did not notify Meta directly. We recommended to the reporter to do that. And that's a really important distinction because the Rust project does not control who gets to know about vulnerabilities. This is not a legal rule. This is just an informal consensus in the security community that it's up to the reporter to have the final say on who gets to know about it. And we just made a recommendation that given you could find vulnerable code in 5 minutes with the first result of GitHub code search, it would be a good idea to notify them in advance, not of the whole details of the vulnerabilities, but just that there will be a release on that date that will affect the security of this project. And in the end, it was just a recommendation. It was up to the reporter to decide whether to do it or not. In this case, they decided to do it. So, what are the conclusions of this talk, and what can you take away from it? First off, you don't have to do this much work for your project. Rust is large, and Rust has a need for this complex of a process. For most small crates, small libraries, and even medium-sized ones, you can have a very more lightweight process that will still handle things good, and for the rate you get a security report, don't expect to have many, if any of them in a year. So what I can recommend to most projects is to have a way to receive security bug reports in private. That can just be a line on the README that says, if you have a security concern, please email my personal email address. That's fine. And after you receive a report, you can wing the rest of the process on the fly. But just having a way to contact you that's not opening a public issue in the issue tracker is good. And also, please request CVEs for all vulnerabilities. They are free, they are good, they are not a stain in your project, and they help everyone working on the security ecosystem. And finally, keep in mind that the reporter is often your friend. Putting often because it's the internet and people occasionally are not your friend. But the reporter is the person that probably knows the most about that vulnerability in that moment. Because if they found it, that means they have experience on that class of vulnerabilities, and it's really important to just talk with them, keep them in the loop, and maybe have them review your fix. They can provide things you missed or more suggestions on how to prevent this problem from happening in the future. And when there is this collaboration, everything goes well. Of course, occasionally reporters goes aggressive and whatever, it's the internet. But try to communicate it, and if things go bad, bail away. So I want to acknowledge everyone who worked on this vulnerability, both the two reporters that also helped with the fix for Unix-like systems, going back to the involved reporters, And also the domain experts, library team lead we looped in, and everyone on the security response working group at the time who worked on the vulnerability. And finally, I want to thank the employers of both me and Josh Stone, for me, Ferrous Systems, and for Josh Red Hat, because they're letting us spend the work time to handle security issues. So all the work we do is thankfully funded by those two companies, and they make sure that the Rust ecosystem is secure by letting us do the work we enjoy to handle security vulnerabilities for the Rust project. And that's it. Thanks everyone, and if you have questions, we can have them, or just talk with me at the conference.